Hey there! In this video, we are going to talk about the debouncing pattern and XState. Debouncing a function means enforcing that it's not called until a certain amount of time has passed without it being called again. We will apply this pattern to XState and we will use it to implement a search as you type functionality. In this little demo, when I click on the increment button, it increments the counter. We want to debounce this operation to only increment in the context the counter when I stop clicking on the button. So I wouldn't spam it. There would be some restriction about when the counter increments. This is a state machine that makes this demo work. This state machine has a context with the counter in it. The initial value for the counter is 0. There is a single idle state, and in this state we listen to click and recent events. When we receive these click events, we increment the counter with this action that performs an assignation with this. So we want to add debouncing there. How do we do? The first step is to create another temporary state I call debouncing. Instead of incrementing directly when we receive this click event, we want to target debouncing. And in the debouncing state, I use the after keyword to define a delay transition. This delay transition, which take action after 500 milliseconds, will target the idle state. We want to go back to the idle state after this timeout, and it will increment the counter. If we run that, we should see that there is something has changed. There is not anymore this floating, but it's not yet debouncing because I keep clicking and the incrementation is done. We don't want that. We want the incrementation to be done only after I stop clicking. So something is missing there, and what is missing is that we don't listen to the click event there. We want to reset the debouncing even if we are in the debouncing state. So to do so, we need to listen to the click events and target the debouncing state again. If we go to the browser, try to increment, it doesn't work. The solution here is to use a re-enter keyword. The re-enter keyword on a transition tells that this state needs to be re-entered when the transition is taken. What re-enters means is you might have entry or exit actions there, and you want these actions to be re-executed even if the next state is the same state. So in the case of a safe transition like this, we want to re-execute the entry, exit, and after actions. And without the re-enter true, it wouldn't happen because you don't necessarily want to recreate timers and re-execute entry and exit actions for each safe transitions. This is why it's not the default behavior, but this is what you want when you need to recreate a timer like for debouncing. So now in the browser, we should be debouncing for real. I keep clicking and the increment only occurs when I stop clicking. This is how you implement debouncing with XState. There is one thing we can do to improve this demo because we don't really know when the debouncing happens. and for the UX it's not really good. We can leverage the fact that debouncing is a state we can target with state.matches to display this indicator, which will have the debouncing word with some icon. What we can do is get the state, which is returned by the use actor hook, and then call state.matches function. If we debounce, then we want to make this visible. Otherwise we want to hide it. So in the browser now, if we increment, there is this debouncing indicator, which makes things more clear. A great thing to note, I think, is how XState version 5 is able to autocomplete the state's name. You can see there that I could choose between debouncing and idle state. This is because in the machine I'm using this new function from XState setup, which improves the TypeScript experience by a lot from what you might have experienced from XState version 4. XState version 4 relied on the type gen to make things type safe, but some parts of the state machine are now type safe by default with XState version 5. So you can see I defined the idle and debouncing states, and XState was able to autocomplete them in the state matches function. This is really great, and I love XState version 5 for this. The best example I can think of on a real-world scenario for debouncing is search as utype. This is a search as utype implementation we will be giving a try. So if I type tailwind, you can see that the request, represented by the tiny icon on the right, is only started when I stopped typing on the field. This way, a request is not made by the state machine underlying on every keystroke, which leads to a large amount of requests, and it might cause some troubles on devices with a bad connectivity. So we want to minimize the amount of requests and make a request only when we are sure it's the right time for it. This is state machine for the search as utype functionality you just seen, and I won't go too much into the details. It might be the subject of another video to re-implement a search as utype mechanism with state machines, but what you need to know is there is an idle state and there is a fetching state in which I invoke the autocomplete search actor which made this request. And when the input changes, we go to the fetching state, we re-enter it. We saw this notion before. It will make the request again, even if we are making a request. So the idea is to discard a request we might do and redo it from the beginning with the new search query. So to implement the debouncing for this, because currently the result we have is this one. When I start typing, you can see there is a direct result. If we open the console, we can see there is a request made for each keystroke. In the autocomplete search actor, this one, there is this console log that is written to the console for every time it's executed, and you can see that for every keystroke we make the request. We want to prevent this and instead rely on debouncing to make the request when we want. So in the state machine, instead of going to the fetching state, we will go to the debouncing state. Again, we create a delay transition with the after keyword, and we'll say after 500 milliseconds, we will go to the fetching state. Instead of fetching, here as a target, we target the debouncing state. And with this really minimal changes, it would work as we expect. Now, okay, so let's type tailwind, and there is a single request made. This is because the debouncing worked. Implementing debouncing pattern with state machines is one of the reasons I love state machines so much. As you could see, the implementation is really thin. We need to create another state, target this state, or instead of the state that makes the request, or call the action that performs an update in the context or elsewhere. And this is so much easier than what you would do with vanilla JavaScript. There will be another video about the other time management pattern common with debouncing, which is throttling, and we will see how state machines make this pattern again so much easier to implement. Thanks for watching, and see you soon!